Challenge day right now. I hope that this video is probably going to be super boring, just straight up, but I hope that you can get through these notes and have a good understanding. I do expect you to learn from this. It's just like I'm there. You just don't have my ugly face to look at. I could probably fix that and just put a picture of me on the screen, but I wouldn't want to torture you. All right, so make sure that you have your lab books out and you've turned to the note page. It's probably page 4, 5, 6, something like that, and it just says concept development at the top. So the first thing it's going to talk about is matter, and hopefully you've heard of matter. Matter is anything that takes up space and has mass. So pretty much just about everything we can think of that is something is matter. Something that it's not would like be feelings and emotions. So clearly they don't matter at all. Um, that joke goes a lot better when I can see you make a face that you think I mean. But I'll pretend I can see you and I'll pretend to hold a straight face and I think we'll just move on. So anyway, matter. Make sure that you know it. This is a matching term on your test and it's just simply anything that has mass and takes up space. All right, we're going to define matter in one of two ways. One of the two ways is heterogeneous. And heterogeneous means not uniform in composition, meaning it is not all just one nice, consistent looking thing. If you look at this picture, I believe this is granite with a, I think, I can't remember what it's called, some sort of element. I learned it in my geology class, and Bert would make fun of me for even attempting it. I think it's blue schist, which is a classic. Anyway, so there's granite and other things inside this rock. Just looking at it, you can tell it is not homogeneous, which will be the next word. It is heterogeneous. There are more than just one thing nice and pretty all together. So if it doesn't look like milk, think about milk. It's all nice and smooth, one thing. And if it's not like that, all right, then it is heterogeneous, not uniform in composition. All right, so next we kind of led into this already. This is homogeneous. That means it is completely uniform in composition. And this would be, like I said, milk. None of us want to get our milk out of the fridge and pour it onto our cereal and have, water, white stuff, and chunks fall out on our cereal. We want it nice and smooth, nice and consistent. We want it homogeneous. And if you look at milk, oftentimes it is described as homogenized because it doesn't come out of the cow in just this nice, pretty white stuff. It's full of fat globules and other things that we won't mention, but it's not all consistent. To make it, they homogenize it. They screen out all those other parts and make other foods out of them. So homogeneous meaning completely uniform. The term homo, hold your laughs, the term homo means one, basically, or the same. So if it's homogeneous or homogeneous, it's all the same. Hetero means opposite of, so if we have those two together, homogeneous means all one, hetero means more than one. All right, so those so far are the first three matching terms you need to know for the test. All right, this graphic here shows you granite on the left is a heterogeneous mixture. Then human blood is also a heterogeneous mixture. You got to be careful there. That depends on your point of view. If we were just looking at blood, like when we gave it at a blood drive, it would look fairly homogeneous. But if we look at it under a microscope, it consists of many different things. So it really does depend on the view sometimes. And then part C is copper 2 sulfate solution. And it is completely homogeneous. It is just simply like sugar water or salt water. All right, next is element. An element, and this is a matching term as well, is the simplest form of matter that cannot be further decomposed by ordinary chemical means. So, if I ever say the word simplest, it just flat out, you need to put that that's the element. We can't break it down through chemical means. We have to use, sorry, my warm, cozy Snuggie just fell off and I had to grab it because my basement's ice cold. What I was saying, in order to change an atom, we have to have a nuclear reaction. In this class, we generally talk about chemical reaction. So an element cannot be broken down. It is the simplest form of matter. Compound, make sure you know this. Compound is matter that can be decomposed into two or more simpler substances by ordinary chemical means. All right, so a simple compound would be like water. We can break water, which is H2O, down into H2 and O2 simply by passing electric current through it. Maybe I'll try and find a video clip of that. Let me see what I can find. All right, give me a second. Okay, I don't know how well this audio will work. But what the heck? We'll give it a shot. So let me arrange this. Mike, hold on.
To a source is direct.
All right, so I hope that was fascinating, and I'm not even sure until after I do this if this will even sound very well. Get back to where we were, but it showed water, which is a simple compound, a combination of hydrogen and oxygen, can be broken down into its parts, hydrogen and oxygen, by a simple chemical reaction. And that reaction is called electrolysis. We just pass electricity through distilled water, and it'll break it into its parts. Now, I can't pass electricity through oxygen and get it to break down into any other parts. Oxygen is an atom or an element. Hydrogen is an element, but the two of them together create a compound. All right, next, the term that we're going to talk about is a mixture. A mixture, it's matter composed of two or more physically blended substances, which literally means I just put two things together physically. Like I just had a bowl of Raisin Bran. It was physically mixed with bran flakes, and yeah, I'm old, okay? When you're old, you eat Raisin Bran. But anyway, some of you like Raisin Bran. I know you won't admit it to your friends, but it's kind of good. But anyway, it is a mixture because in Raisin Bran you have bran flakes and you have raisins. And then I add sugar because I'm still in my 30s. So I want to pretend I'm young while I eat my old man food. And then I added milk. So I had those four things and I physically blended them together. All right, and it says that a key point is that in a mixture, each substance retains its own properties. So in that mixture of my raisin bran, the raisins, even though I added sugar, milk, and bran flakes, the raisins still tasted like raisins. The flakes still went instantly to mush when I put milk on them, and the milk still tasted like milk, and the sugar was still there. Nothing really changed besides that I physically mixed things together. So in the homework, it's going to ask you to name some mixtures. And kids ask me all the time, what are some mixtures? Well, you think of anything in this world that you just mix together physically and you got it. So it could be a laundry basket of clothes. It could be your cereal. It could be the kids in the class. We physically could put you in a mixture. All right? And think of the kids in the class. None of them change just because they're together. Actually, that's a terrible analogy because when teenagers get together, they do stupid things. But anyway, forget I even said that. Okay. Now, in this graphic, up to the top left, you can see just plain purple circles, and that's showing you the atoms of an element. They are all alone, and they are just perfectly by themselves. Over to the right in B, you see molecules of an element. Both of these are still elements because they all have just one color in them. Now, a molecule of an element, some elements will stick together with another one of themselves when they're found free in nature. We call those molecules. Now, down here we have molecules of a compound. The reason why this is a compound instead of just a molecule of an element is we have more than two colors of atoms, which means we have two separate atoms bonded together. Now over here we are going to have a mixture. We have the mixture of the two elements, that's the purple and the yellow, mixed with one compound. I'll call this ammonia, so NH3 if we want, and we'd have all those mixed together. We could physically pull these out and test their properties, and they would be the same as they were before. Okay, now, kind of shifting gears, but still, all these terms on this page are the matching terms from your homework and also the matching terms from your test. And when we're done with this video, we'll show you a couple videos that will help you with your homework. All right, so now we have a physical change. We're going to describe a physical and a chemical change and the difference between them. A physical change alters a substance without changing its composition or properties. All right, so you have to remember, physical does not change the properties. So if you have a piece of paper that you don't mind tearing in half, take it out, feel that paper, feel how it feels under your fingers, write on it, do all the things that you could do to a piece of paper, and then I want you to tear it in half, and I want you to see if you can do the same things you just did to both halves now. And the obvious answer is that you can still write on a paper after you've torn it. The only thing that you've done is cause its change in shape and size. That is a physical change because the paper still retains all of its paper properties, but I've changed it in some way. I've changed its shape and size. So think to yourself, if it ever asks, is it a physical or a chemical change, think to yourself, is it still the same as it was before? Has anything changed? All right, in a chemical change, it is just the opposite. Now things are different. So I won't let you do this, but think of, you have two halves of a paper now. If we kept one half and then we took the other half and we lit it on fire. After we lit it on fire, We would no longer be able to write on it. We wouldn't be able to crumple it. We couldn't make it into a paper airplane. We couldn't burn it again. All the properties of paper after it's burned would be completely different than the original properties of the paper to start with. So that would absolutely be a chemical change. So when you're asked if is it chemical or physical, ask yourself, does anything change? And if the answer is yes, then it has to be chemical. All right. Now, okay, sorry about that. I thought I'd skipped a line for some reason. Okay, now it says to classify each of the following as a physical change or a chemical change. And I want the substitute to go ahead and pause this video right here. And I want you and your lab partners for the next 2 or 3 minutes to talk to each other and decide what you think each one of these changes is, whether it is a physical or a chemical change. So pause it now and answer. Okay, now, I hope that all of you have taken time. I hope that you're even listening because I didn't tell her to unpause it, but Monica's pretty smart. So here we go. Boiling water. So to know this, I ask myself, is water that's boiled still water? And the answer is actually yes. It is still water. It's turned to steam, but steam is just the gaseous state of water. So it's still there. So boiling water is a physical change. It's still water, it's just hotter. All right, next is burning of coal. I hope these are in the same order on your paper. If not, just go with me here. Burning of coal. Anytime you see the word burning, you just need to put chemical and move on. When you light coal on fire, it gives off heat, it gives off light, it gives off smoke. It does all sorts of things, and after it's burned, it is nowhere near the same as before. So that has to be chemical. Cutting paper, we've already gone over. If you cut paper, it's still paper, it's just smaller particles. So you would say that that's physical. Sugar dissolving in water is usually the most controversial here. And write this somewhere in your notes and like on every page of this lab book so you don't forget it. But dissolving is a physical process. It's physical because the sugar is still there. When something dissolves, all it has actually done is gone from a large particle that our eyes can see to a bunch of small particles suspended in a liquid environment that our eyes cannot see. Doesn't mean they're not there. It's just that the size of them is smaller than we can actually see. All right, so that is physical. Anytime you see dissolving, it's physical. All right, melting of butter. Melting of butter is a physical process because it's still butter. It's just warmer. And then finally, Alka-Seltzer tablets in water. We just talked about dissolving, and this will aggravate a few people, but Alka-Seltzer tablets in water is not dissolving. It is actually a chemical change. If you put sugar in water, it just sinks and it dissolves. If you take an Alka-Seltzer tablet and you put it into water, it will produce bubbles and carbonate basically the liquid that it's in. Let me see if I can find a video of that. Fizz, fizz, oh, what a relief it is. I don't know the rest. Fizz, fizz, oh, what a relief it is. This commercial is even a little old for me, but the slogan isn't. You can kind of see it in the background there. I hope that was fascinating to you guys. All right. I tried to find videos, but all I had was old commercials. It's a simple process. You add it, you change the solution completely. All right, so there we go. Physical, chemical, physical, 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 chemical. Hopefully you did pretty well on that. All right, then classifications of substances. We'll take care of that in a different format coming up here. So we have that flow chart there at the bottom. Looks like this. Let me grab this real quick, make it a little bit bigger. Okay, so we're going to fill this in, and this isn't technically a flow chart. This is more of just a diagram showing us how things are separated. So let's go ahead and fill it in. First off, all substances are considered matter. Now, I don't have my normal writing pen. I can't find it, so I'm having to write with my mouse. So you got to be patient with me. All right, when we find matter, we find it in one of two ways. First, we find it heterogeneous. That's kind of a pain, but oh well. We find it heterogeneous. All right, you're going to kill me, but this is the wrong blank. I apologize. Heterogeneous is actually going to come down here in this one. Sorry, we either find it as a mixture. I would hate me too right now. And the mixture is found either as heterogeneous or homogeneous. All right, so a mixture, things that are blended together, they can be heterogeneous or homogeneous. So if I made like sugar water, that would be a mixture that's homogeneous because it all looks the same. But if I made sugar water and sand, that would be heterogeneous because it would look like it is not uniform in composition. All right, over here, so we either find it as a mixture or a pure, I know this is right, substance. Now that's a pain. Now this arrow, in order to make a mixture into a pure substance, we're going to use a physical process. All right, cursive. That's terrible, but it was a lot easier. A physical process to go from a mixture to a pure substance. All right, now a pure substance can either be a compound or you can find it as an element. Heck, my cursive is better than my real writing. I'll probably just keep it that way. Now, if this was a physical process to go from a mixture to a pure substance, to go from a compound to an element is going to be a chemical process. That's not very good, but that says chemical process. So, like that electrolysis where I caused that reaction to happen, I took the compound of water and I broke it down into its elements. And elements on the periodic table are classified in one of three ways. They are metals, non-metals, or, oops, metalloids. You can't really read that, but it says metalloids, metalloids. All right, now we will learn all about those what those three things are on the periodic table as we go throughout this class. Okay, now this is that whole page of notes. I hope that you did learn something in the 25 minutes that we've been watching and doing other practices. Now I'm going to have the substitute show you, or if you're watching this later in the year or as a review for the test, watch the first couple of homework videos that are just below this on the website. So turn to your homework now, try and answer some of those questions and watch those videos and see what you can learn. All right, thanks guys.